The last bit of chapter 3 is about science and pseudoscience. And we're going to go through it, even though you don't have to write down all these definitions or memorize the list. I'd like to talk through them. Okay. Science is not a belief system. It's a system of inquiry, trying to figure out how things work, a way of thinking about it. Get rid of my sidebar there. Okay. So I'll just read through these and talk through them. 1. Science explains observed phenomena through natural causes. If it's not observed, science isn't even going to touch it. Science is not going to touch it. What's beyond the observable universe, I'm not going to touch it. We can imagine, we can talk about it, but it's not science. If you try to do that, you might be in the realm of pseudoscience, which is fake science, or metaphysics, which is not truly science. It's kind of imagining what might be beyond, right? But it's not science. It's not physics. Part of science is often creating and testing mathematical models, right? The idea that the natural world should be quantifiable with numbers. 3 is a big one. If a test is failed, so let's say you made a prediction. This is what I see today. Let me predict what's going to happen tomorrow. And that test fails, you need to move on. Your original guess, your original hypothesis either needs to be altered or just thrown away and start over. Okay. It needs to be subject to independent verification, meaning somebody else on a different part of the world at a different time should be able to reproduce what you just did. So something along the lines of, I saw aliens in the sky and I took a spectra of their spaceship and found out some details about it, is not science because somebody else at a time of their choosing cannot reproduce it. Science isn't going to touch it. It may, maybe you did see aliens, maybe you did take data of their spaceship, but if it can't be reproduced at a time and place of somebody else's choosing, we're not going to call it science. And 5 is, I love 5, will never give a 100% correct model of the world. We are not perfect, our brains are not perfect, our tools for measuring the universe are not perfect. It's never going to be perfect. On the first day of my physics classes, I like to hold up the book and point out, this book is just full of ideas that haven't been proven wrong yet. It's not, we'll call it a law, which might sound more impressive than it is, right? It's not 100% correct. It can't be. We have to leave open the possibility that in the future we'll have better tools or a better understanding of what is actually going on. And go through the definition of a hypothesis, a fact, a law, a theory. In the scientific realm, not just in your everyday language. I say, I have a theory that the restaurant's going to be busy, but that's not a scientific theory. And sometimes even scientists use the word in their everyday language incorrectly, so we have to be careful. If you say you have a hypothesis, it's kind of like an idea. It's something that you want to test out. And it's possible to test out. I'm going to say, I have a hypothesis that the sun is going to rise in the southeast tomorrow morning. That's something I can test out tomorrow morning. A fact is an observation that has been repeatedly confirmed. Not 100% true, just repeatedly confirmed. So it is a fact that we have observed evolution. It is a fact that the Earth's average temperature is rising. They have been repeatedly confirmed. That doesn't mean they're 100% true and we won't eventually tweak it a little bit, but it is repeatedly confirmed. We trust it as much as we can so far. A law, Kepler's laws, the law of gravity, a confirmed statement that implies a causal relationship. gravity will make things fall down, right? Kepler's laws. If it travels on an ellipse, then this is how it will move through the sky. Laws can incorporate facts, envelop them. A scientific theory, not just a theory in your everyday language, but a scientific theory is a well-substantiated, not perfect, explanation that applies in a variety of circumstances. So kind of think an overall idea, a well-substantiated idea that can explain many things. That's a scientific theory. The theory of evolution, the theory of general relativity. Theories can incorporate, include, envelop laws and facts. A theory is more of a larger umbrella. Right? This isn't necessarily in the book, but I have to tell it to every class, every astronomy and energy issues class I teach. It'll serve you throughout your life, right? If you let it, right? Correlation does not equal causation. So here's a lovely plot that I got off the internet that shows number of pirates as a graph versus global average temperature. And it plots them. Oh, look, there's a trend. As the number of pirates decreases, the average global temperature increases. There is a trend, there is a correlation. But does that mean that if you wanted to cool the Earth down, all you would need is more pirates? Does it mean that if you have a pirate problem, which you do in certain parts of the world still have pirate issues, all you have to do is heat the Earth up more and the pirates will go away? There's not an actual link between the two of them. It's just a trend. It's just a correlation. There's nothing actually really making this happen. How about this correlation? As the US spends more money, the green line here, on space and science and technology, the number of suicides by hanging, strangulation, and suffocation also go up. Okay, it's kind of fun to imagine if there's a link between there, but there's not. The link between these two is probably just population growth. Right. Correlation does not equal causation. And my favorite one, as autism rates have risen, what's caused that? Well, let's look at some of the correlations with autism. How about organic food sales? Look at that. Does that mean organic food causes autism? No, not in the slightest. It just means that there's a correlation, but there is no link between them. Maybe it's just the population is growing up. Maybe our environment is affecting us negatively. We're getting higher rates of autism. So maybe people are becoming more aware of that and eating organic. There might be zero relationship between the two things, but it's definitely not causation. If you buy organic food and you eat organic food, there's no link that is going to give you autism. So, vaccines and autism. As vaccine rates have gone up, autism rates have gone up. This has been completely debunked. There's a correlation, but there is no causation. Vaccines do not cause autism. There's been millions and millions of dollars spent trying to disprove this. There was one doctor who had financial reasons to say that there was a link, and that one paper has been since deleted, removed out of the journal it was published in, and he has had his medical license revoked. Right. Which brings me to our next topic of astrology. Now, astrology is an old idea. The idea that the position of the sun and the planets in the sky can affect you and your events of your everyday life. And so I happen to be a Scorpio. So here's Scorpius on the zodiac. And so let me just slide the year around and put Earth in Scorpio. Scorpius. I was born in October. So when the Earth is in Scorpio, it says May. It says May. Well, your astrological sign is your sun sign. So that would be when Earth sees the sun in Scorpio. So right there. I was born in late October. It says November. That's fine. Right? That's when you would see the sun in Scorpius. Which really makes no sense to me. How did they even keep track of that? If the sun's in Scorpius, guess which constellation I cannot see on the day of my birth? Scorpius. Okay. They did keep track of it. They did a good job. Okay. But the idea that that matters, it's been debunked. You can scientifically make predictions. You have to make a prediction and then test it. And the tests only come true at a random rate, right? So my sun sign is the constellation that was lined up with the sun when I was born. So let's say you read your horoscope in the paper, your astrology prediction, and it says maybe you will find love in the next year. Maybe it says you will come into money in the next month. What they do is they're vague enough that you can probably fit it into your life somehow. They're vague enough that you might identify it with your life at some point. But it's really playing on our human weaknesses. There are two things that you really should Google just because it's fascinating. It's more psychology, but cognitive biases means you're more likely to believe something if somebody else does. It's more likely you'll jump on the bandwagon. Right? There are ways that you can play into the cognitive biases of people. It's psychology. And logical fallacies is another thing that you should Google. Just Wikipedia it or something. It's ways that you can get people to believe something that's not actually true. Or make them, make a purchase that they didn't want to. Get them to spend more money. Those two fields there, if you were more aware of how your brain worked and what you're more likely to believe, you can maybe step back and be more alert of what's around you and what you're seeing and how people are trying to influence you. It's totally worth a few minutes on Wikipedia. Astrology as a whole, the idea that the planets' positions affect you on your everyday life, it's not true. You can still read it for fun, but don't believe it.